Hello everybody, I'll be solving a classic problem in Newton's law of universal gravitation. So this problem says that an artificial satellite of mass m travels at a constant speed in a circular orbit of radius r around the Earth of mass m. What is the speed of the satellite? Okay, actually, folks, sorry, this diagram is a bit misleading, but what I'm trying to really show here is that this is the Earth, this is the Earth, and this is the satellite. Okay, and this satellite, as we have been told, has a radius, a circular radius of r, and it has mass m. Okay, so we want to determine what the speed of the satellite is, and note that they're asking for the speed and not the velocity, and that's because velocity is constantly changing, but the speed is constant. Okay, so let's solve this problem. Well, we know that there are two forces, if you will, that are acting on this satellite. Well, two forces that we're concerned with. So there is one force that is the force of gravity from the Earth. The second force is the centripetal force that is caused by the circular motion. Now, we know that for this satellite to be in orbit, it needs to have centripetal force. However, that centripetal force is also equal to the force of gravitation. And once you determine that key fact, this problem just becomes simple algebra. So let's write that down. Let's write that down here. I actually think I'm going to use yellow. Okay, so the centripetal force of that, I guess that results on this satellite is mv squared divided by r. Now we're told that mass is m, and we're trying to determine the speed here, which is denoted by v, and the radius of its of the orbit is r. Now that is equal, as we just mentioned, that is equal to the force of gravity that acts on this mass due to the mass of the Earth. Now we're going to write that as g, that's the mass of the Earth, that's the mass of the satellite, divided by r squared. Now, I know it's glaringly obvious, but just to make sure we're on the same page, this value, this comes from Newton's law of universal gravitation, and this comes from centripetal force, or I guess the definition of what centripetal force is. Okay, so let's solve this problem here. We're trying to determine v, so we can actually right off the bat we can divide both sides by the satellite's mass, so we get rid of the m. We can get rid of the r likewise by multiplying both sides by r. So we're going to get, so this is going to end up being v square equals g times mass of the Earth divided by r. And this, if we square root both sides, we're going to get this. So the speed of the satellite around the Earth at an orbital radius of r is equal to the universal gravitation constant times the mass of the Earth divided by the radius of the orbit, and that number is square rooted, of course. So we've solved this um, this classic problem. Let me know how I did, and thank you for watching, guys.